Assalamualaikum Syukri. My name is Siti Wahida binti Sheikh Kamar. Today we are going to present to you our idea on mobile energy supply solution and monitoring. But first of all, I would like to introduce my teammate Iskandar Zulkarnain and Nur Fareez. So next, So here's our proposed idea titled Energy Monitoring NodeMCU with Relay. So basically it's a bit similar with smart home where we can control remotely our housing electrical load from any internet connected place using a mobile or any other network device. So I would like to explain briefly on how our system works. This project system works using Arduino with the connection of ESP8266 Wi-Fi module that will help the user to control the switching off electrical load in real time using mobile apps. Besides, this system also include power monitoring using current sensor to monitor the amount of current and power consumed, and it will be displayed in mobile apps. Next, next is our objective. The first one is to notify daily energy consumed and electrical bill for home using mobile apps. Second one, easily control the lighting system at home, and to last one is to modernize home management. Next. So this is the list of component. The first one is current sensor, ACS712, NodeMCU, ESP8266, and we are using bulb, breadboard, resistor, power switch, relay, module, and last one is jumper wire. Next. Next, I'm going to explain on our flowchart. The controlling and monitoring of electrical housing started to operate first with Arduino connected with ESP8266 Wi-Fi module. When relay switch is on, the current sensor detected the presence of load that were connected to it, and the current sensor will read and measure the current that flow through the load. This data is transferred to the Arduino that connected with NodeMCU Wi-Fi module that act as microcontroller for the purpose of monitoring amount of current and power consumed when it is connected with load. The analyzed data will be sent to the database and will be displayed the current and power measured through the mobile apps for the user to read and monitor the the data. Okay, next. Next is our block diagram. So ACS712 current sensor will be placed between load and supply to measure the current of the load, and also the ESP8266 Wi-Fi module will act as the component to give Arduino access of Wi-Fi network, and the relay is used for controlling the electronic component that will receive the data from Arduino and execute the command. The relay connected to the load and mobile apps was used as it connected with controller and internet. Next. So we also replaced the NodeMCU with PLC, and here is we are using Delta DVP14SS2T. Next. This is our circuit diagram for NodeMCU. As you can see, the pin A0 on NodeMCU is used to read the analog sensor data from ACS712 current sensor, and other pin D0, D1, D2, D3 are used as the digital input pin. This digital input pin will be connected to the 4-channel relay module. Next. This is the current circuit diagram for PLC. We are using PLC data DVP 14552T. As you can see, I only connected 3 input from 4-channel relay module because this PLC only have 3 output terminal, which is 3 for DC output module, and another one is another 3 for AC output module. Next, I will pass to Iskandar Zulkarnain to explain more about ladder diagram. Thank you.
Okay, this is our ladder diagram. So basically, this is the initial condition where all the current is connected and all the switches are connected. So basically, as you can see under there, these three outputs, Q1, Q2, and Q3 are all open. Okay, this is for initial output. And then firstly, when one of the switches we off them, this is for the when the master switch is off. So when the master switch is off, so basically all the outputs there it will not be there. And this is okay. This one I only off one switch. So as you can see there, Q1 and Q3 is light. Betul, the bulb is on, but Q2 is off. Okay, next. Okay, demo video.
Okay, so the first thing is we get the IP address of our Wi-Fi, and then we copy it and we paste at our localhost server. We make sure our localhost server is the correct, the same, to so that we get the so we can push the right data to the database, and then we get the ID 171 and 5,000 kilowatt per hour, and then we see um, we see the apps are displaying the new data. Okay, so this data is shown that uh, our our total of power that has been used for the 30 within 30 days period, and this 1205 ringgit is our current bill for our for this month. Okay, and then we can see the new data that has been sent from the NodeMCU, which is 5k watt per hour. Okay, and then we make sure the data is correct. Okay, so the next thing we do is we look at our Gantt chart, and from this Gantt chart that our current progress is already at the end of week 14, which is ours now is in about to move on to week 15 for report submission. So this week we have done our presentation, and that's all. Thank you.
Thank you.